Welcome back once again. This is Nick Agram. As I promised, I'm going to discuss series. Okay. Series and sequences, they are related to each other. So, for example, definition of a series is the sum of the terms of a sequence. And the thing that we're going to deal with most of this series of videos are the finite sequences. So the sum of finite sequences, but I'm going to discuss a little bit on infinite sequence and geometric series or geometric sequence. That is what I'm going to do. But to start with, I'm going to discuss just briefly about the sigma notation. So sigma notation is our notation for summing up the terms of a sequence. So for example, if we have summation of u sub k, where k is equal to 1 raised up to n, then we have u sub 1 plus u sub 2 plus u sub 3 plus u sub 4 plus u sub n. That is basically what it is. And then we have, for example, we have sum of k raised to 2, where k is equal to 1 up to 5, for example. Then we have 1 raised to 2 plus 2 raised to 2 plus 3 raised to 2 plus 4 raised to 2 plus 5 raised to 2. Then we have 1 plus 4 plus 9 plus 16 plus 25. Then we have, this is 20, and then 30. Then we have 30 plus 25, that is 55. That's it. Okay. And we have property of this. A property of summation is that when we add a sub k and b sub k in a parenthesis, and it's alright also to just add all the a's and then add all the b's and then add them together. I will prove this. Proof of this will be as an example later. Okay. And then what I can prove now, maybe I can prove it now, is this one. So for example, we have summation of c a sub k, where k is equal to 1 up to n. C is constant, so we have ca sub 1 plus ca sub 2 plus ca sub 3 plus ca sub n. And then we have a common factor, which is c. And then we have a sub 1 plus a sub 2 plus a sub 3 plus a sub n. And this one, we call it a sub k. So we have now c and then the sum of a sub k. Then we prove that. Another property is this one. And then we can give a proof also. So we have summation of c, where k is equal to 1 raised to up to n. Why am I keep on that? And we have c plus c plus c plus c, nth term. And as you can see, this one is c times n. So we have now proved that summation of c, a constant c, it's a constant, then just multiply c multiplied by how many times you're thinking to use k. So if, for example, we have a summation, sorry, it's not easy to use sigma, summation of 9, for example, where k is equal to 1 up to 5, then it's easy. Instead of writing 9 plus 9 plus 9 plus 9 plus 9, then it is easier to just multiply 9 multiplied by 5. Then you have also the same result, 45. Okay, let's take a look of some of the examples that I prepared. Here, consider the sequence. I accidentally used the same example here. Consider the sequence 1, 4, 9, 16, 25. As you can see here, the nth term of this is n raised to 2. Okay, so if we have s sub n now, s sub n is equal to 1 plus 4 plus 9 plus n raised to 2. And we can also use summation notation, wherein we can put n raised to 2, where n is equal to 1. I'm going to use where k, I should say, sorry, where k is equal to 1 up to n. I should have used another letter there. K there. K. Where k is 1 up to n. Okay. Now, find the s sub n of n is equal to 1, s sub n. So our 1, that's 1. S sub 2, we have 1 plus 2 raised to 2, that is 5. S sub 3, we have 1 plus 2 raised to 2 plus 3 raised to 3, that is 9, 10, 14. S sub 4, 1 plus 2 raised to 2 plus 3 raised to 2 plus 4 raised to 2. And this is 20. And we have 30. And S sub 5, I already did it a while ago, but I'm going to repeat here. 1 plus 2 raised to 2 plus 3 raised to 2 plus 4 raised to 2 plus 5 raised to 2. And that is, we have 20. 30 plus 25, that's 55. Okay, next. Expand and evaluate. Here, we have our A now. Then we have is equal to. I'm not going to copy. Then we have 1 plus 1 plus 1 plus 2. 2 plus 1, sorry. 2 plus 1 plus 3 plus 1 plus 4 plus 1 plus 5 plus 1 plus 6 plus 1 plus 7 plus 1. It should be up to 7. Then we have 2 plus 3 plus 4 plus 5 plus 6, 7, 8. And then the sum of that, 10, 20, 30, 5. About B, I am going to use another color so that you will not get confused. B, then we have 1 divided by 2 raised to 1 plus 1 divided by 2 raised to 2 plus 1 divided by 2 raised to 3 plus 1 divided by 2 raised to 4 plus 1 divided by 2 raised to 5. And then we have 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32. Okay, if I'm going to expand everything so that I have the same denominator, so 416 times 2, 8 times 4, 4 times 8, 8 there, and this one is 16. That means I have 32, and this is 16, plus 4, that's 20, and then 8 plus 2, that's 10, so we have 30 already, and we have 31. Sorry, this should be 32, not 22. Okay. There are more examples that I have on summation. I think I'm going to do that in my next video. So hang on, and thank you for watching. As I've said, if you like what I am doing, please subscribe, and or I already link a link PayPal. So if you want to contribute, you can contribute through PayPal. And see you in my next video. Have a nice day.